Welcome back, my friends. Welcome to a very interesting lecture on chemical bonding and LewisDot structure. So first of all, before going into the basic concept of Lewis bond structure, I will try to give some brief introduction about the bonding. So basically there are two types of bonds that are present in different types of molecules. The first type is called the ionic bonds and the second type is called the covalent bond. Now for ionic bonds, now you can see that from the letter ionic you can understood that the participants that engaged in these types of bonds must be ions. So what happened in case of ionic bonds, that among the two atoms that basically form the ionic bonds, one atom completely transferred the electron to another atom. So the atom which completely transferred the electron will become electron deficient, so it will become positively charged or cation, and the atom which will accept that electron will become one electron more, so it will become negatively charged, or we call them anion. So there is some electrostatic interaction or attraction between the two atoms or two ions. One ion is positively charged and another ion is negatively charged, and due to that electrostatic attraction these types of ionic bonds are being formed. On the other hand, in case of covalent bond, the two atoms that participates in covalent bond do not transfer electrons, but they do share electrons between each other because they do believe in equality. Okay, so now coming back to the ionic bond, this is one of the very common example of formation of ionic bond. So you can see that lithium, this is the electronic structure of lithium atom and this is the electronic structure of fluorine atom. So you can see that there is only a single electron in the outermost shell, or we can also call it as a valence shell. So there is only single electron in the valence shell in case of lithium atom, and in case of fluorine atom in the valence shell there are 7 electrons. So in what happen in case of lithium fluoride, lithium will completely donate or transfer this electron from its valence shell to the valence shell of fluorine atom. So what happened now, in case of lithium, it will attain the electronic configuration of helium gas, which is basically a noble gas. On the other hand, after gaining one electron from lithium, its octet will be filled up for fluorine, so it will be get the electronic configuration of neon gas. So we all know that as helium and neon gas are having very stable electronic configuration, so the lithium plus and fluorine minus, these two ions are very stable in nature because they have the electronic configuration of noble gas helium and neon. On the other hand, one lithium ion is positively charged and fluorine ion is negatively charged, so there is a strong electrostatic attractive force that is acting between these two ions, which will form the ionic bonds. So basically the ionic bonds is an attractive force between the two oppositely charged ions. Okay, now coming back to the electronegativity, now this is another term that I am introducing to you, electronegativity. So electronegativity basically is a measure of the ability of an atom to attract the electron. So the atom which has more ability to attract the electron towards itself will have more electronegativity. Okay, so this is a small version of the periodic table. So you can see the trend of electronegativity for various types of atom. Now you can see that if we go to from left side to right side in the periodic table, right from lithium, beryllium to fluorine atom, you can see that as we are progressing from left side to right side of the periodic table, the electronegativity of the atom increases. This happens because as we are moving from left side to right side, the number of positive charge at the nucleus increases. However, the valence shell remains the same, so that's why the outer shell electron will be more attracted towards the nucleus. So that's why they have more electron affinity as we are going from left side to right side. On the other hand, if we go from top to bottom, or we can say if we are going from bottom to top, then also the electronegativity increases. So this is the basic trends of electronegativity that we obtain from the periodic table. So if we see what the electronegativity of lithium, you can see that electronegativity of lithium is 1.0. On the other hand, the electronegativity of fluorine is 4.0. So you can see that there is a large gap of electronegativity between, or large difference of electronegativity between lithium and fluorine. So where the fluorine is much more electronegativity negative atom compared to lithium atom. So that's why fluorine has much more high affinity to snatch the electrons from the less electronegative atom lithium. So you can see that ionic bonds always form between the two atoms which has large difference in electronegativity. Okay, on the other hand, as these types of ionic substance have very strong electrostatic attraction force between them, and both the atoms gains the structure of a noble gas, so that's why these types of bond between the two atoms, the ionic bonds, is very stable and strong. So that's why you can see that the most of the molecules that form ionic bonds are having very high melting points. Most of them are having melting point above 1000 degrees centigrade. This is because of the strong electrostatic force that will make the bond very much strong. So you need very high energy or high temperature to break that strong bond. Okay. Now coming back to the covalent bond and Lewis structure. So basically covalent bonds formed by sharing of electrons between the atoms. They are having similar electronegativity. So when the electronegativities are similar, suppose we are taking the example of a chlorine molecule. So chlorine molecule is formed basically by the combination or by combination of two chlorine atom. So you can see that this two chlorine atom has same electronegativity. So you can see in case of chlorine there are total seven number of valence electrons in both cases. So to attain the octet, what they will do, they will share each of their electron, and you can see that these two electrons are basically the shared electron. So you can see that both chlorine, in case of both chlorine atom, their valential electron configuration is become closed by these types of sharing, and you can see that these two shared electron will form the covalent bond between the two chlorine atom. So these types of thing can also be written like this. You can see, instead of writing these two shared electron, we can show it by some kinds of bond that is also known as covalent bond, where the shared electrons lies in between the two covalent, in between this covalent bond. Okay. Now similar things of covalent bond can be obtained for methane molecule. You can see that in case of methane molecule, carbon has total 4 number of valence electrons. So, and on the other hand, hydrogen atom has only 1 valence electron. So each hydrogen atom, if they contribute or share 1 electron, so if 4 hydrogen atom will share 1 electron each, so in case of carbon, the octet will be satisfied. You can see now the carbon atom has total 8 number of valence electron. On the other hand, the hydrogen will have 2 number of valence electron. So hydrogen will attain the electronic configuration of helium gas, and the carbon will attain the electronic configuration of neon gas. So for both carbon and for both and hydrogen, the electronic configuration for their nearest noble atom is being satisfied. So that's why this methane molecule become very much stable, and they are basically usually written like this. So instead of showing these two shared electron, they are shown by these kinds of covalent bond, where the shared electrons is lying in between these two atoms in this covalent bond. Okay. So similar things happen in case of ethane molecule. Here instead of you can see that single carbon atom, there are 2 carbon atom, and you can see that there are 3 hydrogen atom presence to form the 3 covalent bond with each carbon atom, and there is another carbon single bond is also there. So you can see that both carbon atom has total 8 number of valence shell electron. Now they have their octet field, and hydrogen also they have 2 number of valence shell electron configuration. So that's why they get stabilized by these types of sharing of electrons. So this structure that we have drawn are known as Lewis structure. So you can show the Lewis structure by showing this types of configuration or by these types of configuration. So this is basically called electron dot formula, or we can also say LewisDot formula, where instead of showing the bonding between the 2 atoms, you are showing the paired electrons that basically involved in the bonding. And in this types of dash formula, that is also known as Lewis dash formula, instead of showing this type of shared electron, you are showing some kinds of bonding between these 2 atoms that shared these 2 electrons with each other. So this types of formula is basically known as dash formula, and this types of representation is basically known as dot formula, and they are both are basically Lewis structure. Now it can also happen that some atom can share more than 1 electron. So this is the example of nitrogen molecule, where the 2 nitrogen atoms share between them 3 number of electrons. So you know that in case of nitrogen there are total 5 number of valence electron on the outer shell of the nitrogen atom. So to satisfy the octet rule, they share the 3 electron in between them. So there will be total 3 number of covalent bonds that will be formed in between the 2 nitrogen atom. So this is the Lewis dot formula for nitrogen atom, and this is the Lewis dash formula. Now you can see that out of the 5 electrons, 3 electrons are shared between the 2 nitrogen atom, and in both nitrogen atom 2 electrons are not participate in any kinds of bonding, and these 2 electrons in both cases are known as unpaired electrons. So these electrons that participate in bonding are called shared electrons, and these electrons that do not participate in bonding is called the unpaired or unshared electrons. Now in case of ethylene, that is the formula of ethylene, you can see that in between the 2 carbon atoms they share 2 electrons each. So you can see that both these 2 carbons share 2 electrons each, and they will form the carbon-carbon double bond, and they share 1 electron each in between carbon and hydrogen. So there will be total 4 carbon hydrogen single bond. So you can see that by forming these types of structure, the octet rule is being satisfied for both carbon and hydrogen. So this is the Lewis dot formula for ethylene molecule, and this is the Lewis dash formula for ethylene molecule. Now it is you have to also know that ions can also contain the covalent bond. So this is an example of ammonium ion. You can see that there is one net positive charge in case of ammonium ion, but still there are total 4 number of covalent bond between nitrogen and hydrogen. So you can see that what happened in case of ammonium, as you know that nitrogen has total 5 number of valence electron. So out of the 5 valence electron, 1 electron is being lost. So that's why the nitrogen has total 4 number of valence electron. So that's why the positive charge that is upon the nitrogen atom, as you can see. Now these 4 electrons are shared between total 4 number of hydrogen. So in case of nitrogen, the octet is being satisfied. So you can see that nitrogen, the octet rule is satisfying, and for hydrogen also it attain the electronic structure of helium atom. So that's why why this types of structure is the most stable structure for ammonium ion. So this is the Lewis dot formula, and this is the Lewis dash formula for ammonium ion. Now, how to write the Lewis structure? There are some basic strategy or rule that we will discuss in this slide to determine how we can actually draw the Lewis structure. So there are some basic thing that we have to take care whenever we will draw the Lewis structure for any kinds of molecule. So you can see that first criteria is Lewis structure show the connection between the atoms in a molecule or ion using only valence electron of the atom involved. So you have to remember that in case of the Lewis structure, whatever the bonding that is formed between the two atoms is always involve the outer shell electron. It is not the inner shell electron is not at all participate in any kinds of bonding. So it is the valence electron that is participate in bonding. It may be ionic bonds or covalent bond. In any case of situation, only the valence electrons are participated in chemical bonding. So that's why while writing the Lewis structure, we have to take care of only valence electron. We should not bother about the inner shell electrons. Okay. The next criteria is for main group element, the number of valence electron a neutral atom brings to a Lewis structure is the same as its group number in the periodic table. So you can see that suppose in case of nitrogen, for nitrogen the group number of nitrogen in periodic table is 5. So that's why the number of valence electron for nitrogen atom will be equal to 5. Similarly, for chlorine atom, you can see that if you go to the periodic table, the group number for chlorine atom is equal to 7. So that's why chlorine will always have 7 number of valence electron. On the other hand, for hydrogen atom, it has, or sodium atom or lithium atom, it has they have the group number of 1. So that's why they have only single number of valence electron on its outer shell. So this is another criteria. Now the most important criteria to draw the Lewis structure is that we have to always satisfy the octet rule. In most of the cases there are some exception of this octet rule that we will discuss in my next lecture, but for the time being you have to remember that while forming any kinds of bond, it can be ionic bond or it can be covalent bond, the octet rule should be satisfied. That means that the outer shell should have a closed electronic configuration, that is number of electron in the outer shell should be equal to 8. So that's why it is called the octet rule. Now just get back to some example to show you how these types of Lewis structure is being drawn. Now the first question is how you can draw the Lewis structure of CH3NH2. Okay, so first of all you have to determine total number of valence electron that were involved. So you can see that for carbon the group number of carbon is 4. So carbon has total 4 number of valence electron. In case of nitrogen the group number of nitrogen is 5. So it should have 5 number of valence electron. On the other hand, for group number of hydrogen is 1. So each hydrogen should have only single valence electron, and there are total 5 number of hydrogen atom. So total number of valence electron for coming from hydrogen atom will be 5. So total number of electrons or the valence electron in the molecule is 14. So we have to divide this 14 with 2 to get total 7 number of pairs. So this rule is only applicable when there is only single bond involved in this types of structure, that you have to do remember. In case of each bond 2 electrons are being involved, so that's why this 14 electron, that is for these are called bonding electrons, will be shared by total 7 number of bonding. So that's why we are interested in these 7 pairs. Now the question is that how we can form these 7 pairs. Now out of this you have to remember, or you have to understood that there should be always a bond between the carbon and nitrogen. Okay, So at first you have to form a bond between carbon and nitrogen. Now after forming a bond between carbon and nitrogen, there are 3 more bonds that you can form for carbon. If you form more than 3 bonds with hydrogen, then the octet rule will not be satisfied. So after forming a bond with nitrogen, there are 3 additional bonds that carbon can form with hydrogen. So each hydrogen will share each of its valence electron to form 3 carbon hydrogen covalent bond with this carbon. Now you can see that in case of carbon the octet rule is satisfied. Now coming back to the nitrogen. Now nitrogen has total 5 number of valence electron. So out of this 5 number of valence electron, 1 electron is shared with the carbon atom. So you can see that after carbon atom forming 3 bonds with 3 hydrogen atom, there are 2 hydrogen atoms, they are still remaining. So these 2 hydrogen atom will be bonded with the nitrogen atom. Now you can see that there are total 3 number of valence electron that were involved in bonding in case of nitrogen atom. So you can see that for nitrogen they have total 5 number of valence electron. So out of this 5 number of valence electron, 3 valence electrons are shared between the carbon and 2 hydrogen. So 2 electron will remain as unshared or unpaired electrons. So we have to show the unpaired electron. So this is basically the Lewis dash formula. You can also draw the Lewis dot formula. So in case of Lewis dot formula, instead of drawing this line, you have to show only the shared electron in between these 2 atoms. Okay. So now this is the task that I am giving to you. Write the Lewis structure for difluoromethane and chloroform. So you can try it at your home. So if you have any doubts or problem, please comment down below. Then if you have any problem in solving this question, I will discuss it in a separate lecture. Now another rule is that if necessary we have to make multiple bonds to satisfy the octet rule. So let's take an example of this. Now in case of carbonate ion, so you can see that in case of carbonate ion there are total 3 oxygen that bonded with a single carbon atom. Now you can see that at first you have to draw one single bond with each oxygen atom. So by doing that, you can see that for carbon the octet is not satisfied. Only the 6 electrons are configuration is being achieved by doing this. So to satisfy this octet, the carbon has to form another single bond with any one of this oxygen atom. So you can see that out of this 3 oxygen atom, it will form double bond with any one of this oxygen atom. So you can see that another single bond is drawn. Now you can see that both 4 electrons of carbon atom is being shared between these 3 oxygen electron, and now this carbon atom has a noble gas configuration. And you can see that for oxygen also the noble gas configuration is being satisfied. For these 2 oxygen they have total 8 number of valence electron, and for this electron these 2 electrons are unpaired and they have total 4 shared electron. So for this electron also the octet rule is satisfied. So you can see that in this case the carbon must have to form a multiple bond to satisfy this octet rule. Another example is for ethylene or acetylene molecule. So come back to the ethylene molecule, you can see that there are total 2 hydrogen atoms that are bonded with carbon atom. So to satisfy the octet rule, it has to form another carbon-carbon bond with its adjacent carbon molecule. So you can see that the carbon atom share 2 electrons with its adjacent carbon electron and another 2 electron with 2 hydrogen atom. So its octet gets completed. So same type of logic is also occur in case of acetylene. Now this is the question that I will solve, that write the Lewis structure for formaldehyde. So this is the molecule known as formaldehyde. So you can see that as I have told you that our first criteria is to count the total number of valence electrons that are present in this molecule. So you can see that for carbon it has total 4 number of valence electron, and oxygen it has total 6 number of valence electron, and the two hydrogen, each hydrogen are having 1 valence electron. So 2 hydrogens are having total 2 valence electron. So there are total 12 valence electron. So if all the bonds are single bonds, then there should be 6 pairs. But before that we have to see that we have to draw the first structure is that we will draw the single bond with each of this atom. So at first the carbon will form single bond with hydrogen, 2 hydrogen and 1 oxygen. So by doing this you can see that for hydrogen, but this 2 hydrogen, the noble gas configuration criteria has been satisfied. But for carbon, as you can see that the noble gas configuration criteria or the octet rule is being not satisfied. You can see there are only 6 number of valence electron. So and there is to satisfy this octet rule, the carbon atom must share one of its electron with its adjacent oxygen atom. So both carbon and oxygen atom will share 1 electron each, so that you can see that both for carbon and the oxygen the octet rule is being satisfied. So that's why we reach these types of electronic configuration or these types of LewisDot structure for formaldehyde molecule. Now before we can write some Lewis structure, we must know how the atoms are connected to each other. So before drawing the Lewis structure, we should have some idea that how the bond connectivity are there, because there are some, I will show you by example, that while writing the structure of nitric acid, that is HNO3, there can be 2 possibility that this hydrogen atom can be there is a possibility that this hydrogen atom can be bonded with oxygen, and it can also bond with nitrogen. So in both cases or in both structure, the criteria for octet rule is satisfied in both cases, for nitrogen as well as oxygen. So that's why we should have some prior knowledge about this bond connectivity. The knowledge is that we should know that this hydrogen is only bonded with this oxygen atom. So that is the primary thing that we should have, or we must know how these atoms are connected with each other to get the exact Lewis structure. Now this is another question that is I will solve, that write the Lewis structure for the toxic gas hydrogen cyanide. So you can see that hydrogen has 1 valence electron, carbon has 4 valence electron, and nitrogen has 5 valence electron. So total 10 number of electrons that is participate in bonding. So at first you will draw one single bond with nitrogen and hydrogen, and we'll see whether the octet rule is being satisfied or not. So you can see at first, if you draw the one single bond with nitrogen and one single bond is hydrogen, you can see that by doing this for both carbon and nitrogen the octet rule is not satisfying. So to satisfy the octet rule, you can see that you have to draw an additional 2 bonds, or you have to share additional 2 electrons in between them. So by doing them, you can see that in case of carbon there are total 8 number of electrons, and in case of nitrogen also there are 8 number of electrons. So for both of these 2 atoms, now the octet criteria is being satisfying. So that's why this is the exact LewisDot structure or formula for hydrogen cyanide. Okay. Now before ending my lecture, these are the problem that I am giving you to solve in your home. So you have to draw the Lewis structure for each of these following, that is hydrofluoric acid, methyl fluoride, sulfurous acid, phosphoric acid, nitrous acid. So all those for all this structure you have to draw the Lewis structure, and you should have some prior knowledge about the bond connectivity. So try it in your home. So if you have any problem, please comment down below, then I will discuss all this problem in a separate single lecture. And before ending my lecture, I just want to remind you all guys to please subscribe to my channel that is called the Chembiosis, where you will get latest update on different topics of organic chemistry and physical chemistry. So that's it from now. Take care of yourself. Bye.